Your heating bill is about to spike, and what is happening right now, 30 kilometers above the Arctic, will decide whether you are clearing snow from your driveway in 3 weeks or watching rain drizzle down your windows. This is not a drill. This is not another mild British winter. The atmospheric pattern forming above us is so rare, it has only happened 3 times in the last 70 years. And every single time Britain froze. Here is what you need to know in the next 8 minutes. By minute 5, you will understand exactly why meteorologists are watching their screens with genuine concern. At minute 3:20, I will show you the exact dates when this cold air arrives in your city. And right now, in the next 30 seconds, I am going to tell you the one number that changes everything. 48%. That is the current probability of a complete polar vortex reversal. 2 weeks ago, it was 25%. The odds have nearly doubled. What does that mean for your street, your commute, your energy costs? Let me break this down in a way that actually matters. Right now, as you are listening to this, there is a band of rain moving across Northern Ireland. Winds are hitting 50 to 60 miles per hour on the southwest coast. Wales is getting battered. Southwest England has 3 weather warnings active. This is just Monday. By Tuesday morning, every part of the United Kingdom will see rain. Heavy rain, the kind that floods roads and delays trains. But here is the twist you are not expecting. This rain is not the story. The rain is the opening act. What comes after is what matters. Between 10 and 50 kilometers above the North Pole, temperatures are spiking, not dropping, spiking. The stratosphere, that layer of atmosphere most people never think about, is warming so rapidly that scientists have a specific term for it. Sudden stratospheric warming. It sounds technical. It is not. It is simple. When the stratosphere warms, the polar vortex that normally keeps Arctic air locked over the pole starts to break apart. And when it breaks apart, that Arctic air has to go somewhere. It comes south, toward us. In 2018, a sudden stratospheric warming event hit in February. They called it the Beast from the East. Snow fell on beaches. Motorways froze. The entire country ground to a halt. In 2021, Texas experienced the same phenomenon. Millions lost power. Pipes froze and burst. People died, not from a hurricane, not from a tornado, from cold that nobody saw coming. This year, the warming event is happening in January, a full month earlier than usual. That gives the cold air more time to reach us, more time to settle in, more time to disrupt everything from transport to energy grids to school schedules. But where exactly will it hit hardest? Let me give you city by city detail, because this is not going to be uniform across the country. The north gets it worse. Scotland gets it first. But nobody escapes completely. London. You are looking at daytime highs around 7 degrees Celsius this week. That is seasonal average, maybe a touch above. Rain throughout Tuesday, heavy at times, especially early morning. But here is what changes. Around the 31st of January, possibly the 1st of February, models show a sharp drop. We are talking potential lows of -6 to -8 degrees Celsius overnight. For London, that is brutal. Transport for London struggles when temperatures drop below freezing for extended periods. Black ice on roads, frozen points on rail lines. If this plays out, expect major disruption in the first week of February. Manchester. Currently 6 degrees during the day, 2 degrees at night. Wet and windy through the middle of this week. Winds from the southwest bringing milder air temporarily. But the models are clustering around the same pattern for early February. Easterly winds. That means air coming from Scandinavia and Eastern Europe, not the Atlantic. When Manchester gets easterly winds in winter, it gets cold. Properly cold. We are looking at potential daytime highs, struggling to get above freezing, overnight lows, dropping to -8, possibly lower in suburban areas away from the urban heat island effect. Birmingham. The ensemble data uses Birmingham as a central reference point for the United Kingdom. Right now, above average temperatures. By the end of the month, the spread of forecast models shows massive uncertainty. Some runs keep you near average, but a significant cluster shows sharp cold, the kind where you are scraping ice off your car at lunchtime, not just in the morning. -7 overnight is a realistic possibility. Edinburgh, you are first in line. Scotland always is when Arctic air moves south. This week, 6 degrees, maybe 7. Wintry showers over higher ground already. By early February, if the stratospheric warming plays out as forecast, Edinburgh could see sustained sub-zero temperatures. -6 to -8 overnight in the city, -12 to -15 in the Highlands. Snow is not a question. It is a certainty. The only question is how much and how long it lasts. Glasgow. Similar story. Currently mild compared to what is coming. The west coast of Scotland usually gets Atlantic weather. Wet, windy, mild. But when the pattern flips to easterly, Glasgow loses that maritime influence. You get continental air. Dry, clear skies at night. Radiative cooling. That is when temperatures plummet. Expect lows around -8 in the city, colder in outlying areas. Newcastle. Sat on the east coast, you feel easterly winds first and hardest. This week, 6 degrees, rain and wind. Early February, if the pattern shifts as expected, Newcastle could see daytime highs around freezing, overnight lows of -6 to -9. The North Sea amplifies cold easterly winds. It is called the Ha, that cold sea fog that rolls in. When it combines with Arctic air, it is miserable. Bone chilling, the kind of cold that gets through every layer you are wearing. Leeds and Sheffield. The Pennines act as a barrier, but they also create their own microclimate. Higher ground sees snow first. The models are showing potential for significant snowfall across the Pennines around the 5th and 6th of February. That means disruption on the M62, the A628 Woodhead Pass, the Snake Pass. These routes close when snow hits. They will close. As for the cities themselves, expect -6 to -8 overnight, daytime highs around 1 to 3 degrees Celsius if the cold air arrives as forecast. Liverpool, west coast, so you get a bit more Atlantic influence even when the pattern shifts. But do not assume you are immune. 7 degrees now, 2 degrees overnight. By early February, potential for -3 to -5 overnight. Not as savage as the east coast, but still disruptive, still enough to freeze pipes if you are not prepared. Bristol and Bath. Southwest England is getting hammered this week with rain and wind, 60-mile-per-hour gusts on exposed coasts, weather warnings in force, temperatures around 7 to 9 degrees. But look at the extended forecast. Early February shows potential for a sharp flip. If low-pressure systems track along the south coast and bump into cold air from the north, you get snow. Not just on Exmoor, potentially in the cities. Bath, with its hills and valleys, is particularly prone to cold air pooling. -4 to -6 overnight is possible if the pattern shifts. Cardiff. Wales is split. The coast stays milder, the mountains get crushed. Snowdonia and the Brecon Beacons could see lows of -8 to -9 with heavy snow. Cardiff itself, being coastal, might see -3 to -4 overnight. But if easterly winds establish themselves, even the coast loses its protection. The Severn Estuary funnels cold air, it amplifies it. Norwich and East Anglia, flat. Exposed. No mountains to block easterly winds. When Arctic air comes from the east, East Anglia freezes. Literally. The Fens are famous for it. This week, 7 degrees, rain. Early February, potential for -6 to -8 overnight. Daytime highs barely above freezing. If snow falls here, it settles. It does not melt quickly. Roads become skating rinks, Southampton and the south coast. Usually mild, maritime climate, but not immune. 7 degrees now, 3 degrees overnight. The extended models show interesting developments around the 6th of February. Low pressure tracking along the English Channel. Cold air to the north. That boundary zone is where snow happens. Heavy, wet snow that sticks to everything. Power lines, tree branches, roads. If you are on the south coast and you think you are safe, think again. February 2018 proved that wrong. Belfast, Northern Ireland is getting rain warnings right now. Heavy rainfall, strong winds. But the pattern changes. By early February, the models show potential for northerly or northeasterly winds. That brings cold air across the Irish Sea. Belfast could see -4 to -6 overnight. Snow showers off the Irish Sea. Disruptive, but not catastrophic. The issue is ice. When temperatures hover around freezing during the day and drop at night, ice is everywhere. Roads, pavements, car parks. Let me pause here because I need you to understand something crucial. These are not definite forecasts. They are high probability scenarios based on ensemble data, stratospheric analysis, and pattern recognition from past events. Weather forecasting beyond 7 days is about probabilities, not certainties. But when multiple independent models cluster around the same outcome, when stratospheric warming events follow historical patterns, when ensemble spreads narrow rather than widen, you pay attention. So what is actually happening up there in the stratosphere? Let me explain this without the jargon. Imagine a spinning top. That is the polar vortex. It spins around the North Pole, containing cold air. It is powered by temperature differences between the pole and lower latitudes. As long as it spins fast and stays tight, the cold air stays locked up over the Arctic. Now imagine something pushing against that spinning top, hard, from multiple directions. The top wobbles, it slows down. Eventually, it can split into 2 separate pieces or collapse entirely. That push comes from atmospheric waves, disturbances in the lower atmosphere that propagate upward into the stratosphere. When they break, like waves on a beach, they transfer energy. That energy disrupts the vortex. When the vortex weakens or splits, the jet stream that normally flows west to east starts to meander. It develops big loops, big bends. Those bends create blocking patterns. High pressure sits over Greenland or Scandinavia and refuses to move. It blocks the normal Atlantic weather systems from reaching us. Instead, we get winds from the east or northeast. We get air that has traveled over frozen Siberia, over the Arctic ice cap, over Scandinavia in deep winter. That air is dry, it is clear, and it is bitterly, savagely cold. The time lag between the stratospheric warming and surface impacts is typically 10 to 14 days. The warming event that scientists detected in mid-January puts surface impacts right around the end of January and into early February. The timing lines up. The pattern recognition lines up. The ensemble clustering lines up. Here is what makes this event particularly significant. Stratospheric warming events in November are extremely rare. Only 3 recorded in the last 70 years, 1958, 1968, and 2000. In all 3 cases, cold weather followed in December and January. This year, the event happened in late November and early December. We are now in late January. The lag time is playing out exactly as it should. The Canadian long-range model, updated today, shows continued cold air support over North America and Northern Europe through February. The European model shows blocking patterns developing over Scandinavia by the end of this month. The American model shows easterly winds establishing across the United Kingdom by the first week of February. The AI-enhanced European model, which often picks up pattern changes earlier than traditional models, already shows the easterly flow developing by day 5 of its forecast. This is not one rogue model. This is cross-model consensus. And consensus matters. But let me give you the counter-argument, because I am not here to scare you. I am here to inform you. Not every stratospheric warming event produces dramatic cold weather at the surface. Some dissipate without major impact. Some produce cold spells that last only a few days. The atmosphere is chaotic. Small changes in initial conditions can produce wildly different outcomes. A low-pressure system tracking 50 miles further north or south can be the difference between rain and snow, between mild and freezing. The ensemble spreads, those bundles of forecast lines you see on weather charts, still show variability. Yes, there is clustering around colder outcomes, but there are also warmer outliers. Runs that keep Atlantic systems moving through, runs that prevent blocking from establishing, runs that bring milder air back within a week. The most honest answer I can give you is this. The probability of significantly colder than average weather in early February has increased substantially in the last 2 weeks. It is not guaranteed, but it is likely enough that preparation makes sense. So what does preparation actually look like? Not panic buying, not stockpiling, just sensible, practical steps. If you have not serviced your boiler, do it now. If you have pipes in unheated spaces like lofts or garages, insulate them or leave heating on low even when you are out. If you rely on a car for commuting, check your antifreeze levels, tire tread, and keep a scraper and de-icer in the vehicle. If you take medication or have medical appointments, plan for potential transport disruption. For businesses, especially those with delivery schedules or temperature-sensitive operations, this is the time to review contingency plans. Cold snaps do not just affect whether you can get to work. They affect supply chains, energy demand, infrastructure resilience. For schools, particularly in Scotland and Northern England, be prepared for potential closures if snow arrives as forecast. It is not about overreacting. It is about having a plan before you need it. Let me give you specific dates to watch. These are not predictions. They are watch windows based on current model consensus, 29th to 31st of January. This is when models first show potential for pattern change. Watch for winds shifting from southwesterly to easterly or northeasterly. Watch for overnight temperatures starting to drop more sharply. 1st to 3rd of February. Peak window for cold air arrival if the pattern shifts as forecast. This is when models show the highest probability of sub-zero temperatures across much of the country, 5th to 7th of February. Potential snow risk, particularly if low-pressure systems track along the southern half of the country and interact with cold air from the north. This is the classic setup for significant snowfall events in the United Kingdom. After the 10th of February, uncertainty increases dramatically. Some models keep the cold locked in. Others bring milder air back. Too far out to call with any confidence. Now, here is what I want you to do. Comment below with your city or town. I will be monitoring model updates daily, and I can give you more specific local detail as the pattern develops. Weather is intensely local. A forecast for London does not help someone in Inverness. A forecast for Manchester does not help someone in Plymouth. This comment section becomes a resource. A place where people share real-time observations, where you can see what is actually happening in towns and cities across the country as this develops. It is crowdsourced, hyperlocal intelligence. It is valuable. Also, bookmark this because I will update if the pattern changes significantly. If models shift away from cold, I will tell you. If they shift toward even colder outcomes, I will tell you that too. Transparency matters, honesty matters. I am not interested in clicks. I am interested in giving you information you can actually use. Let me address one more thing, climate change. Because someone always asks, how can we have a cold snap if the planet is warming? Climate change does not mean the end of winter. It does not mean the end of cold weather. What it means is increased variability. Warmer average temperatures globally, yes, but also more extreme swings. Milder Decembers followed by brutal Februaries. Heat waves in spring followed by late frosts. The atmosphere has more energy in it. That energy drives bigger swings, bigger disruptions, more volatile patterns. Stratospheric warming events may actually become more common in a warming climate. The science is still developing, but there is evidence that Arctic warming affects the stability of the polar vortex. A weaker, more wobbly vortex means more frequent disruptions, more frequent cold air outbreaks, even as the long-term trend is toward warmth. So no, a cold February does not disprove climate change. It is consistent with it. It is part of the new normal, a normal where nothing is normal for very long. Right, let me bring this back to what matters for the next 72 hours. Because the long-term pattern is one thing. The immediate forecast is another. Today, Monday, the 26th of January. Rain across Northern Ireland, southwest England, South Wales. Heavy at times. Winds 50 to 60 miles per hour on exposed coasts. Temperatures 7 to 9 degrees in the south, 5 to 6 degrees in the north. Wintry showers over Scottish mountains. Tonight into Tuesday morning. Rain spreads east across the entire country. Very wet start to Tuesday. Weather warnings remain in force for Northern Ireland, southwest England, South Wales, and southeast England. Overnight temperatures around 4 to 6 degrees. Mild for January, but windy and wet. Tuesday daytime, rain pushes north. Winds remain strong, especially in the southwest and Wales. 50 to 60 mile per hour gusts continue. Some clearer skies possible across southern England and Wales by late afternoon, but showers continue off the southwesterly flow. Snow possible on highest ground in Scotland and the Pennines, where rain meets cold air. Temperatures 6 to 10 degrees, but feeling much colder in the wind chill. Wednesday onward. Still unsettled, more rain, more wind. Atlantic weather systems continue to dominate. But watch for subtle changes. Watch for winds starting to back more northerly. Watch for overnight temperatures dropping more sharply. Those are the early signs that the pattern is beginning to shift. The models are converging on a transition point around the end of this month. Not definite, not certain, but probable enough to keep on your radar. Let me show you something interesting about ensemble forecasting. When you have 100 different forecast runs, each with slightly different starting conditions, you get 100 different outcomes. Early in the forecast period, those outcomes cluster tightly. Everyone agrees on tomorrow's weather. By day 7, the spread widens. Some runs are colder, some milder, some wetter, some drier. But sometimes, even at day 10 or day 14, the spread narrows again. The ensemble members start to agree. That is what is happening now with the early February period. The spread was wide a week ago. It is narrowing. More and more runs showing similar outcomes. Easterly winds, blocking over Scandinavia, cold air moving south. That narrowing is significant. It means the signal is strengthening, not weakening. I mentioned earlier that the probability of polar vortex reversal is now at 48%. Let me put that in context. A month ago, it was around 15%. 2 weeks ago, 25%. The trend is upward. Confidence is increasing. If the reversal happens, if the stratospheric winds actually flip direction, the impact window extends. It is not just a few days of cold. It is potentially weeks. The reversal changes the entire hemispheric pattern. It locks blocking into place. It keeps Atlantic systems at bay. February 2018 saw a reversal. The cold spell lasted nearly 3 weeks. March came in still frozen. I am not saying that will happen this year. I am saying it is possible. I am saying the mechanisms are aligning. I am saying this is worth watching closely. Here is the final thing I want you to take away. Weather matters. It is not just small talk. It is not just background noise. Weather affects how you live, how you work, what you pay for heating, whether your children get to school, whether your trains run on time, whether your pipes burst, whether your business operates normally. Understanding what drives weather, understanding the patterns, the cycles, the atmospheric physics, it gives you agency. It lets you prepare. It lets you make informed decisions instead of being surprised. Right now, we are in a period of genuine uncertainty with a bias toward colder outcomes. That is the honest assessment, not fear-mongering, not clickbait, just probability based on the best available data. The next video in this series will drop on Thursday. I will cover the Wednesday night to Thursday model runs, show you updated city forecasts, and break down any changes in the stratospheric pattern. If the cold signal strengthens, you will know. If it weakens, you will know that too. Comment your location below. Subscribe if you want daily updates. And check back Thursday for part 2. The atmosphere does not care about our schedules, our plans, our assumptions. It does what physics dictates. Right now, physics is pointing toward change, significant change. By mid-February,